Okay, welcome to this session where we will continue discussing about the natural restoration law. There are many ways we can look at this law, from the government, from the administration, from the legal aspects that we discussed this morning, and also from a technical point of view, because there are many challenges that we need to solve. We need to identify, we have discussed this before, we need to identify priority areas. We need to figure out how to allow real participation and so on. So we have a wonderful session here because we are going from Finland, as far as I remember, to the very south. So we will have very different views on how the different European member states are trying to solve the challenge of developing these national restoration plans from this technical point of view. At the end of the session, we will have 20 minutes for discussion. I really encourage you to stay here for this 20 minutes discussion, which is a precious time to wrap up the two sessions and then discuss about the implementation of the design and the implementation of the plans. I didn't mention Chris Declerc from IMBO and leader of the Science Policy Interface at SERE Europe, and myself, Jordi Cortina, we will be chairing this session. So let's go ahead. Melinda Halassi from Hungary.
Hello, everyone. I'm a scientist, a restoration ecologist, but also on board serving in SERE Europe. And today's lecture is based on the work of a large group of institutes and people, and I'm really a little tiny part on it. Sorry, it does not move forward. I probably
Can you open the presentation?
Assistance. No. Press this one. Yeah, I pressed that one. Okay. So restoration prioritization is done in Hungary under the framework of green infrastructure development. And with the challenges that we face, there are several questions. And in this preliminary state, we focused on 5 steps that are probably related to 4 basic questions. The first is the conditions, ecosystem conditions. The second is, and the third step is about where restoration is needed. The 4th step will be about restoration targeting, what type of ecosystems should we restore, and finally some answers to the where we should make some restoration. So in the green infrastructure development framework, they consider, according to the definition, not only ecological condition, but also multifunctionality and connectivity. So we took into account these 3. And of course, a big challenge is where to get data from, especially at the country scale, and especially detailed data enough to draw decisions. And we were in the lucky situation that in this project, another pillar on ecosystem services provided a base map of Hungary on ecosystems. They provided evaluation on the ecosystem condition and also on ecosystem services. However, these results depend mostly on data availability. And also in this project, they considered ecosystem evaluation within the major ecosystem types, so comparing agriculture to agriculture, forested land to forests. And instead, in green infrastructure, we aimed for comparability across ecosystem types. So our first challenge was, how can we translate the scale to a single one? And here you can see the major figures for the state, and you can recognize that for grasslands you have only 2 values, 3 or 5, and this assigns the lack of data. We don't have enough data on grassland quality. The second step was estimating multifunctionality, and again we could rely on this NESTE project for ecosystem services, but which ecosystem services to take into account during restoration prioritization. And this we use regulating, supporting, and cultural services, but we excluded provisioning services because they are often in trade-off with the rest. For example, agricultural production is a service, but it destroys the environment. And if multifunctionality is considered in Hungary, you can see the map that yellow areas are quite large, so there is low multifunctionality in more than half of the country. And the third axis for green infrastructure performance assessment is connectivity. And again, here there are several challenges. First, how to compare connectivity of freshwater habitats and terrestrial habitats and in between. So for water bodies, we use the Water Framework Directive data. And for terrestrial habitats, we created a composite index of habitat connectivity and fragmentation. But in this, we could consider only some generalistic animal or plant, and it is not specific, for example, to a next species. So once we had a performance assessment, the second step was green infrastructure zoning for conservation and restoration aims. Of course, the best quality areas were prioritized for conservation. Medium quality areas were prioritized for ecosystem enhancement, and the worst quality areas where natural ecosystems were almost completely destroyed and replaced by agriculture or non-indigenous plantations are the area where re-establishment is possible, and it is almost half of the country. And here are the maps. So for protection, we have around 300,000 hectares. For improvement, around 1 million hectares, and almost 7 million hectares where it is possible to theoretically to re-establish native ecosystems. We handled connectivity separately. Colleague László Kolányi created this potential ecological corridor maps. Here he considered only the best quality ecosystems, level 4 or level 5 of at least 15 hectares, and used the least cost path analysis to create the new possible network. So this was about where to restore, what is in need of restoration, and you could see that we still lack information on annexed habitats and species. We should harmonize our data with those. And we also lack the favorable reference area to account for. The second step was to check what kind of ecosystems should be restored in the possible area that are sustainable without intense human management in the future. And for this, we use the multiple potential natural vegetation models that we have for the whole territory of Hungary. These predict a range and also the probability of ecosystems that are sustainable under the given climatic, hydrologic, and soil conditions. And here you can see the 3 maps of potential forest, grassland, and wetland areas according to present conditions. Please note that these maps overlap. So in one location, you can have either forest or grasslands or a mosaic. And also these are for the present climatic conditions, but now the model is improved to consider climate predictions, short-term and even long-term climate predictions. The fifth step of this spatial prioritization, considering land use conflicts and feasibility. In land use conflicts, we intend land use of a given area is not appropriate for the environment. So therefore, environmental threats may arise, and it can lead to decreased ecosystem services or even to decreased ecosystem conditions. We considered 5 major land use conflicts: inland excess water, water erosion in arable lands, deflation-sensitive areas. We also considered arable lands in water quality protection areas and non-native plantations that are hotspots for invasive species in Hungary. And if you create a composite map, and if we can prioritize restoration actions where several conflicts arise, then we gain more. And in final step, we considered feasibility in terms of stakeholders' willingness to restore. We considered ownership. Of course, state-owned or private-owned lands are different. And we considered production status in favor of restoration and soil production value that is prioritized mostly for arable cultivation. And if you intersect the different layers for prioritization, you can achieve your goals where to prioritize various restoration efforts. Here, for example, on the map below, you can see where grassland re-establishment is possible according to models overlapped with the conflict map. And at least one conflict arises on almost 60% of Hungary, and 2,000 hectares, we found 5 conflicts at the same time. And if we overlap this map with Natura 2000 areas, then we still have around 100 hectares. In our research group, we further thought about the line of what to restore and how, using multiple potential vegetation models, abiotic conditions, landscape naturalness, and natural regeneration capacity. We used only highly potential areas where we considered also the mosaic that is in orange on this map. We used decision tree method to determine thresholds for different abiotic conditions like sand content, elevation, groundwater, and precipitation. And for similar methods for the landscape scale, but in a more coarse map, where we considered naturalness of sandy habitat and extent of all natural habitats and natural capital index. And for what to do, we considered regeneration capacity locally. We have, fortunately, data on this on Hungary. Of course, if regeneration capacity is high, then you can rely on passive restoration and spontaneous processes. Otherwise, you need active interventions. And we also have data on how ecosystems can spread to neighboring land or abandoned fields, and that help to determine actions at the landscape scale. For example, if there's dispersal limitation, we can see it from decreasing trajectory, and then we can build corridors. So these are about the basic scientific data until now. And now there is fine-tuning. We have a new project for fine-tuning and especially for determining a monitoring methodology for the future. What we still lack is guidance and best practices and estimation of resources, especially cost, to further elaborate restoration prioritization and green infrastructure development. And besides this scientific part, we also try to motivate people to get engaged in the implementation of nature restoration law. We initiated the Hungarian Restoration Knowledge Hub. We tried to get involved other stakeholders, especially forestry, agriculture, and water authorities. And we also start communication to the wider public, as there is no one else to say anything in favor of nature restoration law in Hungary, except for WWF. So thank you for your attention, and I'm ready for any questions.
Thank you very much. Thank you very much, Melinda. It's an impressive work that you have developed. We have time for just one question, because we are a little bit behind the schedule. Because remember that we have these 20 minutes at the end, so we can raise questions for the presenters too. Then, please, be as brief as possible.
Santtu Karaksala from Finland. How did you prioritize? Oh, and thanks for it was very impressive work. But how did you prioritize between the habitat types? So do you have different values for different type of habitats that you might restore, which we have found in Finland to be very good way to increase the cost effectiveness of restoration actions in prioritization?
We did not prioritize across habitat types to date. Yeah, it is a very hard question. So now we have, if it's possible to restore at all that kind of habitat type, but other issues like best practices, knowledge, finances, other resources should determine prioritization further. And the main aims, even at the governmental level, like absorbing carbon or going for diversity, it depends. Thank you.
Okay, thanks a lot, Melinda. Now we go to, please. We move to France, Aurélien Carré and colleagues from Patrinat. Yes. I'm sorry, Patrinat.
So hello everybody, so I'm Idaline L'Aigle and I will present this presentation with Aurélien Carré, my colleague, and we work together at Patrinat, which is a state service aiming at giving scientific advices to the government, the ministry. So first I will present you the key challenges we identified in developing the National Restoration Plan. We had global challenges, which are identified the implication of the restoration law for different sectors, what are the co-benefits, for instance, and how we can improve public policies coherence, and how we can mobilize different stakeholders. Sorry. So it's how we can make the restoration law percolate into all the sectors and be handled by all the stakeholders. So this is really global challenges, and we also have some specific challenges for which we are in charge in Patrinat, which is first how we define the best restoration measures and where we put them in place. So it's to know where are the habitats we need to restore. And also we have a big challenges about monitoring the restoration efforts, and so how to put the restoration objectives into existing programs, for instance. So the specific challenge about the Annex 1 habitat is to know where they are, which is a really, really big challenge, and especially where in what state, what condition they are. So which are the habitats we need to preserve, to restore, or to evaluate, because we don't know where they are, but we don't know in what condition they are neither. And also where is the best place to reestablish habitat. So it's a big mapping and data analysis to do, and also to know where are the additional area we need to improve quantity, quality, and connectivity for species of the habitat and bird directives. And I leave my Thank
you. So we wanted to give an overview of the main challenges and then focus on only Annex 1 habitats. And I will also show you the strategy that we are thinking about to collect data on Annex 1 habitat distribution and condition. So first, the main data on those habitats is the data that we collect for the Habitat Directive. And the first one is the data were reported in the Article 17 reporting, for several years now. It's about the distribution and the condition of those habitats. So we have maps like using 10 by 10 kilometer grid cells. We also have data on the area, conservation status, and trends at the biogeographical level. And these assessments, they are done like every 6 years based on the broad consultation of experts. They use like existing knowledge data that they can have, or they also use experience in Natura 2000 site, but it's mostly based on their own knowledge. And as I said, this process is only done every 6 years, and so in between there is not like a monitoring scheme for those habitats. And moreover, this data is only like made to be used at the biogeographical level, and so it's not detailed enough for the requirement of the natural restoration law. We know that an habitat can be in bad condition at the biogeographical level, but we don't know where, especially its area is degraded. We also have data from the Natura 2000 site. It covers like almost 20% of the mainland France area, so huge surface. We have the standard data form that can be that gives information for each habitat in each site. What is this area or the percentage of the site that it covers? We have data on its degree of conservation, not conservation state. So it's a different way of seeing the condition. But we see that at least at national level for now, we are working on it, but the data is incomplete and not really up to date for each site. And it's really heterogeneous, like each site is managed by a local stakeholder, and they have all their different view of how to assess the condition of an habitat and whether to decide that it's degraded or not. So we had to figure out how to complete this data with new program, like ongoing or maybe new to develop. One major project that is going on in France since maybe 10 years or even more is the CARAB program, the Mapping Habitats program. And it's a modelization of two main components of habitats, like biotopes, that are a homogeneous surface defined by a combination of physical parameters and vegetation physiognomy that are combined to produce like maps of specific habitats for this project, the CARAB habitats. And through expertise, we can translate those habitats into UNIS typology or Annex 1 typology. But still, for these Annex 1 habitats, we can only know their potential occurrence, where it's highly probable or probable that they occur, and whether they are dominant or not in these CARAB habitats. So we are developing a sample strategy to really see how predictive this model are, and also trying to test a simplified method to assess whether the habitat is degraded or not in these habitats. Another thing that we will be really grateful to use is the first biodiversity monitoring scheme in France. It was just adopted like earlier this year, and it's the first time that we have a scheme that is built on the 6-year logic, like as the same as the Habitat Directive, to produce long-term series of data on biodiversity to answer national and EU issues. And it should allow us to articulate between the scale at the European, the biogeographical regions, national level, and also more locally, like region and departments, and also have different set of data for the different protected areas. And it will give us data on the conservation status of species, all of the species that are protected under the Habitat and Bird Directives. It will also focus on some Annex 1 habitats, like at least for the next 2 years. Like we will finally have data for all forest habitats using the National Inventory of Forests. We have a specific protocol for dunes that will be implemented within the next 2 years to assess their condition in a more quantitative way than it was done before. And one specific habitat, the 7240, that also benefits for a national protocol to be assessed. And this monitoring scheme will allow to have like the actual condition and situation, and also provide support in monitoring the different biodiversity indicators that the nature restoration law will ask us to do. We are also looking at how to use local data and most importantly, like large-scale remote sensing assessments. We are like launching a research project on how remote sensing can help monitor the condition of some habitats at the really large-scale level. Another set of data that we will try to look into is to use data on pressure. We now have a set of different maps of pressure on biodiversity, so we know how intense these pressures are and what are the extent at the national level. And if we work more on the sensitivity of habitats towards these pressures, we could probably or potentially like have idea of the condition of habitats where the pressure can occur. And finally, finally for now, but we also have other data, but one very important set of data that we can use is data related to species. We have millions of data on species occurrence and life traits. We have a specific database that is aiming to document the relation between species and habitats, like how strong the relation is and how valid, when it is valid. And so this data is available for most of the protected species, but work is still needed. And it can help to quantify the need of species for the quality and quantity of their habitats, or provide indicators for assessing the condition of habitats. And also it can provide insights to quantify the favorable reference value, like how big an habitat should be to be in good condition. That is really a tricky and a really difficult topic to assess.
So briefly, how we can combine all this diverse data and prioritize restoration needs. So how you could see, we have really various data from different geographic scales, which is really hard them to combine them to have a global view of the localization and the condition of habitats. First, with the Habitat Directive, we have data at the scale of the biogeographic regions. And also we have programs or monitoring programs and budget for a restoration project at the administrative regions scale. We also have the Botanical Conservatory, who are in charge of a lot of habitats monitoring project and restoration project, who work with other geographic scales. And then we have protected area, who also have their own project and are their own scale. So it's really, really hard to combine everything and to do something at the national scale. And also we have various stakeholders working with restoration or habitat monitoring. First, we have the ministry in charge of ecology, who is in charge of overseeing the implementation of the restoration law and delegate some of the power, let's say, to administrative regions, who are then in charge to guide the stakeholders to restore area, and they give budget and so on, which is also one of the role of the biodiversity office. Who give guidelines, try to monitor and gather all the data at the national level. And so we try to make a network of all the restoration stakeholders, and we have the luck to have already a network which is REVE, so the Network on Ecological Restoration in France, which is kind of the SERE but at a national level. And this is really nice to help gathering stakeholders and data. And it groups mostly scientists and practitioners and helps to share information. And we also have some relay hub on specific ecosystem, for instance, a peatland hub, who are really useful to share information. But then we have the agriculture and forestry sectors, which is a little bit not far, but disconnected, would say, to these networks. And it will be really nice to gather everything, everyone into the restoration objectives. And for this, we are thinking about information system, like a big hub where we could gather all the data, protocols, definition, guidelines, and so on to help the implementation of the restoration law and especially the writing of the national plan. And to finish, just to say that France is not beginning the work. We already have some strategy, for instance, a national strategy for protected area, for biodiversity, that comes from bigger engagement, for instance, international and European engagement as commitments, as it was already presented. So the wheels are already running, and we just keep going forward, and the restoration law is another step. But we we are going into this. Thank you.
Thank you very much. One question. There's so much information. And go ahead.
Maybe I can just shout.
Because online.
Sorry. I just wanted to ask, it seemed quite terrestrial what you presented. Is there any aquatic or freshwater in there, or is that done somewhere else?
Well, yes, we choose to only focus here on Annex 1 habitats and terrestrial ones, but the French Office for Biodiversity was the former institution in charge of the freshwater and the assessment under the Water Framework Directive, so there is a specific team working on that. We will have meetings to try to link the assessment of the waters with the Annex 1 habitats, and we are also doing the same work for marine habitats and also indicators, but yeah, that's specifically terrestrial.
Okay, thanks a lot, Idaline and Aurélien. Our next speaker is my colleague, Mchiz Derak, from the Regional Directorate of Forest in northern Morocco, and he will discuss our prioritization in Spain, in forest habitats in Spain.
Hi, everybody. Well, my talk will be on the identification of priority areas for ecological restoration, addressing specifically forest habitat in Spain. Sorry. Okay. As we have been seeing during previous talks, the European Nature Restoration Law encourage European member states to develop national strategies and plans that respond to European directives, but at the same time maximize ecological and social benefits. In large-scale restoration strategies, and as my colleague just said, guidance is needed to direct effort toward the most cost-efficient restoration outcomes and identify landscape where the effort of restoration should be concentrated and addressing or targeting multiple restoration benefits. So in such large-scale prioritization strategies, it is interesting to have some contribution that help to define action frameworks, identify data needs and knowledge gaps, and also provide guidelines for action and lower scale. In Spain, there is an important traditional technical and scientific background to revert land degradation and carry out restoration actions. And there is various administrative and legislative tools that have been developed to set up an ambitious restoration strategy. Here I mentioned the Strategic Plan of Natural Heritage and Biodiversity for 2030, the National Strategy for Green Infrastructure, Connectivity and Ecological Restoration. And furthermore, there is an important effort that is done to fulfill the Spanish commitment to develop the own national restoration plan. And there is a considerable work that has been done to establish guidelines, so directives and criteria for restoration at national scale. In Spain, there is an increasing interest in identifying priority areas for restoration at regional scale using multiple criteria selected and assessed by multiple stakeholders, but this is only at regional scale. Here we can see an example of a prioritization exercise carried out in the Valencian community, in which the priority areas have been identified according to the opinion of three main groups of stakeholders: those interested or working on biodiversity issues, the environment issue or agriculture and other disciplines. And we can see that, there was a kind of agreement on the most critical area to be restored soon. But at national scale, there is still a lack of such prioritization strategies. So the objective of the present work is to develop a special multi-criteria approach to identify priorities area for restoration across Spanish forest habitats under the Habitat Directive, to generate recommendations and guidelines to support restoration policies and instruments at national but also at subnational scales, such as that of the autonomous communities, and assess existing information and identify gaps. The method adopted in this work is divided in two main steps. So the first step is to characterize and map current state of conservation or degradation of habitat. I should highlight here that initially we wanted to carry out the study for all the habitat types in Spain, but because of lack of homogeneous information and comparable data, we decided to carry out the study on that type of habitat that that had the most, let's say, the precise and accurate information, which is in this case forest habitats, addressing also biodiversity issues. So the next step is the development of special multi-criteria model that identify priority areas for restoration using multiple criteria. So environmental criteria, such as vulnerability to climate change, landscape connectivity, risk of wildfire, risk of floods, but also we used socioeconomic criteria. Here, for example, rural development, human pressure footprint. In this table, we show a brief description of each of the criteria. So risk of wildfire will be assessed using short and medium-term probability of burning in basis of already done work by Duani and the team. For vulnerability to climate change, it will be assessed using the risk to drought evaluated already by Fongob Foundation. They used 16 indicators of environmental aspects, and combining all the indicators, so they addressed a global index of risk to drought. And this index will be assessed using the extensive network of the plot of the third forest inventory. Landscape connectivity address eco-profile connectivity that may allow identifying corridors to be restored at national scale. And data is available from the database of Spanish Ministry of Ecological Transition and Demographic Challenge. The risk of flood is meant as areas of significant potential risk of floods using database of the ministry. For the socioeconomic criteria, we will assess rural development using optimal rural area to invest according to the methodology developed by Alonso and Massot. Environmental zoning for renewable energies also is assessed in accordance to sensitive to energy infrastructure with environmental that have environmental impact. And finally, human pressure footprint is assessed in the sense that assume a kind of causality between human pressure and habitat degradation. So the basis of the work, or the start point, is the map of habitat, the map of forest habitat. We use the map of forest habitat at the scale of 1 by 50,000, elaborated from the forest map in Spain, which details the habitat in 4 levels, and the detail and the description of the vegetation associations and the type of habitat is detailed increasingly. So, for example, for the level 4, the description and detail of the habitat is high, and there is a correspondence with the type of forest habitat with the habitat type of community interest. So the assessment of the habitat condition could be comparable with European directives. So the baseline map is, so the baseline, and the first step is the assessment of forest habitat conservation level. We assessed it according to the parameter related to specific structure and function. Here we used the map developed by Del Barrio and the team. They used an index called Normalized Index of Relative Severity based on water use efficiency. So the index gives idea of the level of severity and determining levels or intervals of the index. We could generate a kind of classification of the condition of degradation or conservation at the national scale. And here we can see that 60% of the forest habitat in Spain are under favorable condition. 35% are in unfavorable bed conditions, and 5% are in unfavorable inadequate conditions. As you can see, there is a contrast of condition between autonomous community, between habitats that will be analyzed further. And I should highlight that the analysis will be carried out at the polygon level. So for each polygon, we will assess the level of each of the remaining criteria, and then we will combine it all the values for the criteria together to get an integrated value for the polygon according to all the criteria. And I should add that this aggregated index will be analyzed also giving or considering a constraint layer, which is the land property. So to see the suitability or the chance of success of the restoration in, for example, in private forests in comparison, for example, to public forests. So that's it. The work is running. We don't have all the results here to show, but maybe some conclusion to highlight that such approach may enhance the credibility and transparency and also the efficiency of decision-making process linked to forest restoration at national scale. The final priority map is not an end in itself. It helps decision maker at a different level to plan their restoration actions, and autonomous community can apply and adapt this this methodology according to the specific environmental and socioeconomic, but also political context. In such special multi-criteria exercise, there are many challenges that we faced, especially the availability of comparable spatial data in terms of accuracy and spatial resolution, collection data. So this were heterogeneous nature of data gathered from different autonomous community. So a big challenge is to harmonize this all this information and to produce an information that can be applied similarly at the national scale. So that's it briefly. Thank you for your kind attention.
Okay, thanks a lot, Mshish. Again, one question for Mshish.
Hi, from here.
Aurélien.
A similar question to the previous one, if there's any link with freshwater habitats, especially in relation to your criterion on the risk of flooding, because often if you take into account the other targets, restoration of lateral connectivity has to do with restoring flooding frequency and extension. So how did you put together the two objectives? The easy way to put it is, how did you use your criterion on the risk of flooding in your prioritization?
Okay. So we consider that the areas under potential risk of flooding are somehow priority in terms of restoration. So a high risk of flooding means vulnerability, high vulnerability. So either in the upstream of the watershed or the lower parts of the watershed. So high risk mean high vulnerability.
So it's based on the catchment. There's already existing map of potentially flooded areas. So we plan to use the catchment draining on these areas that can be flooded. Okay, thanks a lot, Mshish. The next speaker, I already introduced Chris Declerc. We talk about the bottlenecks for upscaling ecological restoration.
Good afternoon, everybody. I'm from Flanders. I will not talk about the tools we have in place for bottom-up evaluation of condition of our natural areas and potential for restoration in Flanders. We have a lot of tools. Instead, I will give you a more general presentation on the different bottlenecks we face as a scientific community for the ambition and the implementation of the nature restoration law. So I will, during my presentation, give you some working points, some suggestions for things, food for thought for yourself or for your team you are working in. First of all, we have a pretty good knowledge about what the main bottlenecks are, thanks to the paper led by Jordi, and out of 21, I recommend it to read. The different bottlenecks were all ranked according to Delphi process. So we know the most important ones, and these are the 10 most important ones. And what is striking is that, contrary to what we as ecologists, which are most of you in the room, well, there's actually not in the top 10 real proof that the lack of ecological knowledge is a major bottleneck. There's only mentioning of lack of monitoring data and evaluation. But most bottlenecks have to do with financial aspects, insufficient funding, harmless subsidies, lack of compensation for landowners, financial returns for landowners, or sociocultural bottlenecks, conflicting interests between stakeholders, lack of collaboration between sectors, and so on. Also, a lot of legal constraints, bottlenecks that need solving, and sociocultural bottlenecks. So, these are the 33 bottlenecks. I will not read them. You can find them in the paper. So let's have a flashback moment to the legislative process that the proposal of the nature restoration law followed. After the proposal, we immediately saw massive campaigning of people and sectors opposing the proposal for nature restoration. There was a lot of misinformation, a lot of unfounded arguments were sent to society, like all the jobs would go to China from now on, or Europe will be struck by a famine. So food security was in danger. Also, the green transition was in danger. And as a scientific community, we coordinated a lot of scientific evidence and make it available to policymakers and the wider public. These are just two examples. Also a lot of efforts, as you heard this morning, by the legal working group. Also in the declaration of Alicante of 2 years ago, we mentioned a lot of priorities and evidence. But all this, well, it doesn't seem to have helped a lot. And this is very frustrating because, yeah, you provide scientific evidence, you hope that it is taken into account. And what you see is that in summer of 23, only 2 member states were opposing the nature restoration law. In 24, it was 6 member states opposing. So apparently, well, we were not so successful. Of course, it has to do also with the farmer strikes we faced in many member states, and also mainly conservative political parties that suffered from some election fever. But the situation, the consequences, despite all our efforts, were really bad. Not only the weakening of the nature restoration law, but also some important environmental legislation that was whipped off the table, like the 4% of agriculture land for biodiversity. The pesticide regulation proposal was off the table, and also conditionalities in the common agriculture policy will be weakened, was announced. Again, the scientific community loaded itself up, and society co-authored in this important declaration, raising our really concern of the rollback of environmental legislation in the EU. So again, on this initiative, we got very few reactions. So it comes to mind inevitably that somehow, if we provide scientific evidence for some people or part of society, it only resembles another opinion. So that's a problem we face. So we fail in our communication to bring the evidence to the table and that it is taken seriously. So from that observation, I like to propose a few working points for our community. So first of all, we are not trained for communication, so we should maybe consider engaging with real experts in communication, how we should bring over our message as scientists. Perhaps we should have more face-to-face talks with politicians, so come out of our scientific bubble and go and speak at the European Parliament with the members of Parliament. Maybe we need more scientists also engaged in politics. We need to be more visible to the wider public in news and talk shows. During our training, maybe we need more courses on how to deal with media and also about policy making. So second series of working points are about the conflict management, so and stakeholder participation. Everybody has another idea of what nature is, and some think it is a cow and a tree and a grassland with just one species, but they don't know better. So there is this problem of shifting baselines, and we need to overcome that. We need to inspire the people of how the landscape could look like after restorations look for cultural connection as well. And I think there's also a big need, as it is in the law, it is obligatory to involve stakeholders for participation, but in fact very few governments or administrations are experts in how to do this. So there are many different ways of organizing stakeholder participation. And here I think our social scientists, colleagues could really help by providing best practice guidance, how to communicate to farmers, to fishermen, what are the do's and don'ts, etc., what are the experiences in the field. Of course, we also need cost-benefits guidance. Benefits can be a powerful argument to win a discussion on a particular point. And we also need much more good demonstration projects. And it's important that the scientific community identifies them. This is a good demonstration project, and we'll have to give the credits to local ambassadors who can show that to their peers, and then their peers will maybe be inspired to do the same. Other series of working points, we all are convinced we need transformative change. We have multiple crises for our society, which we need to overcome. I think we need much more knowledge and data on life cycle analysis of the current way we operate as a society, especially for the unsustainable practices. And also to show that we need to fade out harmful subsidies in that respect. Also identify alternative socio-economic models. Farmers are sometimes stuck, are often stuck in a particular model. They can't get out. They should show how they could have a different model of income in their case. Socio-economic value of ecosystem services. We all talk about cost and benefits, but make the benefits visible. So multifunctional approaches, One Health approach are important. And also it's not only ecologists here, but our economic colleagues, social experts, legal experts, health experts that need to be involved. Another important point for my observation is that we, as researchers, we often work separately from the policymakers. We produce a report, we send it to the policymaker, and then we hope it is taken into account. No, I think we have to work together and with practitioners, with policymakers, and also bridging the different sectoral approaches, sectoral policies, water, agriculture, climate, spatial planning, biodiversity policy is really in the middle of it, and we need to work differently often than we are now working. This is an example of also an appeal for the global biodiversity framework to work more closely with the people dealing with the Paris Agreement. And we are all in the same bat, and we need to find solutions, and they are better integrated, or we work maybe not in a constructive way with each other. Optimized knowledge sharing, it has been shared already many times today. For those people who don't know these publications, I really can recommend you to have them on top of your desk and read them, because they will inspire you, and will guide you how to do the restoration in practice. These are a few points of working points. So we need, in the assessment phase, in the planning and design phase, the implementation phase, and monitoring and evaluation, we need standards of practice. And some of them have already been elaborated. Can't go into detail now, but the guidance better be also barrier informed. So what do you want to reach, and what is blocking you? So the barrier informed guidance will be more productive, I think. It should be produced in the language that policymakers and practitioners understand, should be synthesized, regular updates, attractive, visual, to training programs, and scientists have a role there to train the trainers. E-learning platforms can be generated. And of course, we also need guidance on cost-benefit analysis and guidance of trade-offs and synergies, for instance, between climate and biodiversity or agriculture and biodiversity and so on. So there's a lot of work we can do here. And finally, I'd like to share this model of collaboration that we should pursue, where in a European context, we try to bundle the knowledge from all the experts that are out there. And we promoted this figure since the beginning since the proposal of the Nature Restoration Law 2 years ago. So how the collaboration, structural collaboration, could benefit the member states and the knowledge sharing and the underpinning of ambitious nature restoration plans. And we are very happy to see that actually the Biodiversa Plus consortium took up this challenge. And in Paris, there was this meeting where it was decided to establish this knowledge hub. And I mentioned, if you want to know more, there's a session Wednesday, tomorrow at 11:45, if you want to know more about this knowledge hub. But perhaps more importantly, and I'm nearly finishing, more importantly is that we know that restoration always takes place at the local scale. And communication between local people is always in a specific context of cultural context, a legal context, language context, socio-economic context. So for me, it is extremely important that we try to find a model, if we want ambitious national restoration plans, where all these experts, scientific experts, come together and talk to each other with policy people and practitioners to underpin the national restoration plans for also at site level, to train practitioners and managers to organize monitoring and reporting. And this needs to be embedded in a structural form of collaboration. And if you think this is useful, we could also mention this in the conference declaration as a point of attention to really push the member states to have this kind of structures in place. And we learned also that in Hungary there is an initiative, but I want to give the Dutch initiative here, mention it briefly, because I think it worked very well, providing that there is enough financial security for organizing this collaboration. And perhaps in the discussion, the Dutch people can testify how it works and we can discuss it more. So thank you for your attention.
Thank you very much, Chris. I'm sure we will we're running out of time, so I'm sure we will have the chance to discuss about knowledge hubs and the details of OBN later on. Now, the floor is for Sanne Popelier from Wageningen.
Hi, everyone. Since I only have 5 minutes, I'll give you a tiny sneak peek into the challenges that we face for nature restoration in the Netherlands. So it's a bit preaching to the choir, but we also have Natura 2000 areas which are protected under European law, and here you see them in green for the Netherlands. And also in the Netherlands, we have a huge problem with nitrogen deposition, which kind of hinders the restoration of these areas. And it's the darker the color here on this map. Do I have a pointer here? Yeah, the darker the color, the higher the deposition. So you can see that it's pretty bad in the Netherlands. And also, in our country, the combination of this high nitrogen deposition and the demands of the European Union led to this so-called nitrogen crisis. So we also had angry farmers protesting in The Hague because in 2019 it was decided that you couldn't do any substantial economic activity before nature restoration. So this kind of led to the Netherlands being locked down, so to say. And that's why the government introduced this program of nitrogen reduction and nature improvement. And within this program, the government gives all kinds of subsidies for nature restoration measures. So then provinces and site managers, they started making all these documents, like giving an overview of what they're doing in their areas and what kind of measures they are taking to make a plan for restoration. And then the government asked our institute specifically to give an overview of the progress and also the effects of these restoration measures. So that's why in the beginning of this year, this first edition of this 2-yearly report came out. So actually most of the colleagues that worked on this report are also in the room. And in this report, we try to kind of aggregate all the monitoring data on all these restoration measures to kind of give an overview of the progress and the effects. But unfortunately, mainly when it came to the effects, we could not draw that many conclusions. And I want to illustrate that with a few examples. Because, you might know if you want real causal relationships on the effects of the measures, you need to do experiments, and those are very costly, and we don't have that kind of data. And if you want to use other data to say something about the effects of measures, some problems arise in areas with high heterogeneity. For example, in this area, which is the Drentse A, and this is, according to their own description, one of the best preserved lowland stream systems in Europe. And for Dutch standards, it's quite large and complex. And one of the issues is that we have multiple owners, and they all have their own data management systems where they keep track of things. So if you want to aggregate the data, it's really hard because it's really variable. And another thing is that if you take restoration measures, there can be a big difference in the effects depending on where you are taking the measures, if it's more upstream or more downstream, or in different management types. So if you want to have a proper overview of all these measures, you really need high-resolution data. But then you also have some issues with that. So here you see an example of what happens when you try to aggregate data to a higher level. So here on the y-axis, you see all different management types, and the colors indicate the different qualities of those management types, depending on some kind of rules of species occurrences. And then you see a picture for the whole area. But if you try to calculate the same thing for example, here the 2 sub-areas, 4 sub-areas, or even 250-meter grid cells, you see a different, more nuanced picture. But then the picture for the whole area becomes a kind of virtual reality. But this is not the only way in which information can get lost in translation, because there is often a big discrepancy between the ecological goals and the policy goals. So site managers, they have a lot of really nuanced knowledge, but if you try to aggregate this information to a higher level, you lose all kinds of information. But this more abstract information might actually be useful for the policymakers to justify the money that they spend. So you have this tension between getting to know your area and do some experiments and learn from all the measures that you're taking. And on the other hand, you want to justify the money that you spend. So this is a really complex system. So I guess this talk was a bit of an introduction to, or an invitation. If you're working with similar issues and you have any ideas for us or suggestions, please come find us during the rest of the conference. So thank you.
Thank you very much, Anne. And now the floor is for Santtu Kareksela from the Parks and Wildlife in Finland.
Okay, hello everybody. Nice table here. Nice to be here also. Yeah, I'm trying to walk you through in approximately 5 minutes in how we have been approaching this analysis for strategical decision making for protected areas and how to react to the threat of climate change in the future. It has a little bit more content than for 5 minutes, but let's see how it goes. Was it this one to change? No. Where do I need to point it? Well, this is how the time flies best. Any tricks for this? Oh, I suppose I just did something. Aha, wasn't me. Okay. What did you press? This one? Oh.
I think so.
Okay. Makes sense. It's the arrow one. Okay. Hope it works now. So I guess we can all agree that we need to somehow a little bit look ahead for the future challenges, and it's quite important to have some understanding on how things will be changing in the future, and how perhaps quite largely with the same methods as how we do restoration and ecosystem management, how to react also to the changes caused by the climate issues, and also where we need to do it. But I guess we also agree that we probably can't react to everything, so we need to kind of be able to choose our battles, and this of course leads us to prioritization. And this is, in this slide, just going a little bit through the basic ideas that what kind of data we need, and probably the most intuitive one is that we need to have some idea how much the climate is changing and where. And this is of course kind of European level data. It's not that accurate, but it's still at least very good at trying to build up this kind of approach. And on the other hand, we need the data on how vulnerable the habitats are. Exactly, it's spatial data. If we have habitats here and the climate is changing this much there, how it's affecting the habitat. That's kind of what we're looking at. It doesn't really matter if the climate changes if the habitats don't change. So we kind of really need this data. But this still doesn't really kind of give us the idea that so what? So what if we have a habitat A somewhere and it changes? So what? Was it important habitat? Was there important species there? So we also need the data on irreplaceability of the different protected areas. And it of course has big differences, at least in Finland. Finland we have a lot of I think even the Natura habitat type abundances are differences between the most abundant and least abundant Natura habitat type in Finland is 1 million-fold. So it's a big difference if we lose this really small one, or if we lose same amount of something really big. So we can use this kind of information to calculate the irreplaceability and use it or make a spatial prioritization analysis out of it. So this is what is, in my understanding, most often missing in this kind of priorities, that we are looking at that what if we restore something or add something, or what if we are losing something, but what is the meaning of the part that we are adding or losing for the whole protected area network. And basically we have this kind of data. We have a spatially explicit and habitat-specific climate change model data in Finland that we are using currently. And it has 6 different factors. It's looking at with respect to climate and how the habitat patches at different areas of Finland, how much they are going outside the current window of conditions. And then we have the protected area network level irreplaceability analysis, which consists of, first it's for 1,500 protected areas, about 5 million hectares that has been analyzed altogether, and threatened species data and the habitat data and connectedness in the landscape that we are looking at. We get results like this. We have on the left the heat map for the irreplaceability, and then different kind of climate projections, the next 2 maps. And we can identify cases like this where we have, the red is always kind of a higher value, and bluer is lower value. So we have high irreplaceability value on the map on the left, and then we have kind of media core climate change value in the middle, and how much the climate is changing at that spot. And then on the right map we have how many factors actually went outside this habitat, all those habitats over there, then on their current climate window, or what kind of conditions the habitat is occurring currently, how many factors went outside. And we see it's not that severe. On the other hand, here we have another case where we see that all of them are red. And this of course already gives us ideas that, okay, we probably have different situations. We need to react probably differently to these cases. And this leads us to this, I guess it's formally announced to be by US government, this resist, accept, direct concept, or the National Park Service in US, and this is of course something that how you react to any changes. You have basically these 3 options: you can resist, you can accept, or you can try to do something about it. And so it's not really a habitat change concept, although it's talked about like that. So we have basically a matrix now which includes the climate change habitat patch level and how the habitats react, and so kind of what is going to happen, and then how important the factors it is that we are likely to miss. And we get different kind of outcomes, which then kind of refer to us as different kind of this resist, accept, direct
needs. So if there's no change and it's not that important site, we probably don't need to worry about it. And even if there's kind of change, but it's not important, it's probably something we don't want to use that much money on. And then on the other hand, there's the areas where we might even have change and important, we want to react, there might be too much change, and we might have to just accept. And then there's actually the fourth one is quite interesting, that we can identify areas which are important, but there's no climate change, which are probably going to be refugee areas for these quite irreplaceable areas, at least looking at like that currently. And we need to stop every other threats there. If they are saved from climate change, probably not a good idea to put a mining site next to them. And this leads us different kind of information. It probably needs to be more accurate, the analysis in the future, but still we can already think about what kind of trade-offs we are looking at and identifying the magnitude of the problem. And also we now have a national scale strategy because of the national scale level irreplaceability analysis, and we can then apply this at protected area level management planning. So we're kind of thinking big but acting local, which seems to be pretty good strategy, at least for now. So that's all for me. Thanks for listening.
Thanks a lot. Well, first of all, thanks to all the presenters for compiling and compressing all the information in 15 and even 5 minutes. I think we are all aware, with a general feeling that it was impossible. And there's much more, we need much more time to discuss these issues and to talk about prioritization, to talk about scales and so on. We have seen examples from Finland, from France, from Hungary, from Spain. I'm wondering if there are other examples that have not been shown here on experts that are struggling to develop these prioritization schemes and to gather the information to build these natural restoration plans. We have 10 minutes now to discuss about this. No more. I'm sure that there will be, because it's a must now that the law has been passed. What do you think about, that's Renaud?
Yes, thank you for all these presentations. And I would like to react to the very last words of the last presentation. Think big and act local, no, yes. And that was my question, and also the question of Sebastian, which is left, and Delphine and Elise. We were wondering how to integrate local knowledge of very site-specific managers. And because such big maps are really interesting, and I think they are really useful to plan national plan for restoration. But then how to use the local knowledge of someone who knows that there is a degraded area that we can restore, we know how to do it, but just we don't have any budget to do it. And how to gather this knowledge to go back to the top-down approach and to mix these two approaches together.
First reflection as a kind of answer is we should also look at the legal obligations. The legal obligations are very clear. At the local level, we need to have non-deterioration in the future, and we need to go to good status. So it is, to me, really absolute essential that we incorporate the local knowledge, and because the local managers, the local people, they know best what are exactly the environmental pressures here. They can point their finger. That's the problem. So these are the data that we need to capture and need to be part of this overall national restoration plan. And of course, the top-down approach with these maps and modeling we saw is useful and can be inspiring, but to me is of secondary importance. So the law is clear, the local level is the important level to look at. So I don't know if that is an answer.
If I can add on that, the approach that we are taking in Spain, I think you raise a very important question of scale. And I think we should avoid, I agree with Chris, that I wouldn't say that is secondary, but is we must avoid using these large-scale maps to perform restoration, because we can create disasters. The quality, I think, has been general comment here that the quality of the maps are still very low, and even if we improve them, they are not at the scale of execution. So we must figure out how to work at different scales and combine this information, which is relevant. It is large-scale information and overview of priority areas and so with lower scale. Because, for example, the criteria, I don't think the criteria at the large scale should be the same at the lower scale. We must develop plans that allow these different scales, because if we want to engage local practitioners, we need to respond to their aspirations and incorporate those criteria in the planning.
Yeah. Sorry, I could just answer, since it was the maps I presented. That so I'm working in Parks and Wildlife Finland, and we are basically in charge of all the protected areas in Finland. So we can perform analysis like this, and then we can incorporate it into the planning process in Parks and Wildlife Finland. So it's basically our regional experts who then can tell that whether or not some results work or don't work. We also have very specific this habitat data for all of our protected areas, which have been done through field work through many decades now. So we have actually very, very, very high quality data on the habitat patches and their condition, and which we can use for restoration prioritization, but also for this kind of threat purposes. So in this case, it works quite nicely, but of course there's still challenges. And when we perform analysis like this and then show it to our planners, then their first reaction might often be quite critical on that. How can you perform national scale analysis and then come to tell us that this is how they should work. But then in the end, when we look at them together, then usually the synergies are found. And it also, for strategical tool, they are very good for that kind of work.
I would like to add only one comment and an experience. For example, in Hungary, and I think the situation is similar in many countries, it's very hard to get the local knowledge. If you don't go there, don't talk to the person in face-to-face, and don't write you down all the experiences, you will never get the knowledge, because they don't have time, they are not interested, they like to do the things and make things move, and all the rest of the people should take care of gathering knowledge and stuff like that.
Hi, I just wanted to add a comment in relation to this strategic planning and prioritization. So my name is Rachel Christensen, and I'm one of the co-chairs from the Nature Restoration Law Knowledge Hub with Vito over here. All the member states right now are going to be asking the same questions and going through these same things, these issues with parameters, challenges, what to look for, how to measure it, what scale to use. One of the things we would like to share, invite of all of you here who are going through these challenges and asking these questions, is to please submit your findings, your successes, your issues to us via email, and we can incorporate this into the Knowledge Hub and submit it to our hub. And then we can disseminate and share this knowledge with each other and learn from each other's experiences. Each member state doesn't need to reinvent the wheel in this space, and working together and coming up with solutions together, I think, will help facilitate the NRL implementation and also make it more efficient for the member states. So I just wanted to add that. Thank you for everyone sharing your studies and your findings, and please come up to Vito or I, and we will be doing the session that Chris spoke about at 11:45 in the Menanon room tomorrow, and we will share a bit more about the Knowledge Hub in that time. Thank you.
Thanks a lot, Rachel. Boris?
Thank you. Hello, everyone. My name is Boris Barov from the Society for Ecological Restoration. I would like to make a comment after listening to the presentations, and they were really interesting. There are lots of issues of technical character, of scientific character that are to be solved and discussed and debated. But from the list of prioritized barriers, I think the most important is stakeholder collaboration. especially at local level and on the implementation level. And I think this is the job of the future in Europe. Restoration facilitator. Someone who can talk to the stakeholders, who can make the stakeholders talk to each other. And this is something we really at the moment need desperately for to unlock the implementation of the nature restoration law. So if I was to look for another job, that will be perhaps one of my top choices nowadays. Thank you, on that positive note.
Thank you, Boris. I think all the universities and training centers should take note of that. Yeah. Sabine?
Hi, I'm Sabine Tischew from Anhalt University. Thank you a lot for all those presentations. But what I missed a bit are indices or an assessment of the biodiversity status when selecting the priority areas. So that's a question. Particularly when we are talking about forests, we should also think about which share of native species are going in the forests. Of course, the ecosystem functions and services are important, but we also have to talk about restoring biodiversity. So by selecting the area, we have to think also about that. And the second point, I want to congratulate Boris. That would also be my favorite job, to be a local restoration facilitator or something like that. We need a kind of infrastructure, kind of a service within the regions to find priority areas where we can implement restoration measures, because all the local stakeholders are interested in that. And that's the solution for successful restoration. So, but the first one was a question.
Or does somebody want to answer what Sabine asked, or before I ask?
I completely agree, but I think that the challenge in this conservation status, there are different levels, and then we can estimate the function, for example. And in Spain, we're using this already existing information about function based on rain use efficiency. We also have information, but I'm not sure that it is a statewide information on the biodiversity status of that. But definitely we need to take into account all the different levels of defining the conservation status, for sure.
Okay, so I'm Vicky Temperton, Leuphana University in Germany. So I was wondering, I like the point at the front about not reinventing the wheel. And I'm kind of wondering, because with the talk by Derek and from your group, Jordi, you mentioned that there wasn't enough data to look across all the habitats, and so therefore you chose the forests. And I'm wondering whether this is the case in other countries, or whether this is just a particular case of Spain, because we know we have biome biases and all these other issues in the background as well. So it would be very important that we first work out, do we have more data in specific habitats, and is this a general thing in Europe, or is it in one country you have more data from one habitat, and the other country it's a different habitat that's got better data? That would be very important to check. And then to work out, does this affect what we then do, right? Just a sort of flag.
I completely agree, and I think we have seen the contrast between some countries, like Finland, that they have very much advanced on that, and others that may not. So I think we need procedures. We need to establish ways to exchange information and to advance on that. The fact that we work with forest habitats, it was circumstantial, because we need to deliver these maps urgently, so we were forced to use existing information. We could not produce new information, and the best information we have on habitat maps and state is that one. So
I know, so that's fascinating. So that's what I mean, is then we should find out, is this the case across the EU, or is it different? And then
sort of act based on that. Yeah, it's fascinating.
Absolutely agree.
Mm-hmm.
Yeah, we can.
Yeah, thank you.
Sorry, Chris. There's also very easy methods to prioritize between habitats. Not really, you don't really have to have spatial data on where they occur, but also that gives you then the priorities that when you do surveys and then you find it, that then knowing at that spot that if this is a priority or not. And that's kind of one very easy way to do it, which I guess most this kind of a biodiversity related prioritization analysis work on is the relative increase to different things. So we have, for example, in Finland calculated the cost effectiveness allocation of resources between different Natura habitat types for the total amount of 1.2 million hectares we thought that was expected from us for the restoration law by 2030, which is quite a lot, 1.2 million hectares by that time. But when we calculated that to which habitats we can make a big difference, so how large proportion or how much area for each habitat type is in good condition currently, given the knowledge that we have. It's not that accurate, but it still makes the difference between these habitat types. And some of them are really small scale, and some of them are absolutely huge. So if we do 1,000 hectares restoration for aapamyres in Finland, we get maybe 1% or 1 promille addition to what is in good condition. If we do 1,000 hectares of oak forests in Finland, we will maybe double or triple the size. And this means that we have kind of very abundant habitats, and then we have this low end or kind of a large end of habitats that are very small scale. And concentrating on this gives us a lot higher cost effectiveness for restoration. And it doesn't cost that much to do all of them because they are so small. And when we rearranged kind of or just simply put the restoration target, which is actually not habitat specific anyway. So we just decided that what happens if we would restore areas according to their cost effectiveness, so basically low cost and high increase per hectare to those habitat types, and do 100% of the degraded area for each habitat type, as long as we get this 1.2 million hectares altogether. And compared to the solution where we would do 30% for each habitat with the same 1.2 million hectares, we would achieve it with our cost efficiency or effectiveness method. We would achieve it with third of the costs and with 3 times the effectiveness. So 3 times relative increase to these habitats on average compared to what is good condition right now. And it's very simple. It takes maybe 1 hour to do this kind of exercise. It's not necessarily bulletproof, but it's a lot better than doing it not considering the cost effectiveness differences between habitat types. It's very, very, very simple. But it just kind of, and it's how most of these very detailed and hi-fi analysis actually work there. What it doesn't do, it doesn't consider that is it a good combination over your country, but still habitat by habitat, it's a lot better than not doing it like that.
Thank you. We should be closing the last option.
Yeah, I will keep it short. Just a comment on the word prioritization, which is used a lot during this discussion. I understand where it comes from, but I like to recall again what the restoration law says. So we need to restore by 2050 90% of the habitats in good condition, 100% of the favorable reference area to realize that good condition by 2050. So it's not a matter of prioritization. You can prioritize in time, but it is everything of important nature that we have that we need to bring in good condition, or and at least in complying with the non-deterioration obligation. And also for assessing the condition, I recall that there are criteria for that. Unfortunately, the Commission in the Habitats Directive gave the autonomy to the member states to invent their own mechanism how to assess good condition, and perhaps that is fine, but it could help, of course, that there is more guidance on how this good condition needs to be assessed. But I would say prioritization, you can prioritize in time, but all nature we need to protect. And just as one small to-do thing that I find personally important is we are talking about halting biodiversity loss. Now, we didn't talk much about it, but in fact it's also about that, halting biodiversity loss. And we have all this red list data, but no one has a database where we can really look in my area where I have to do restoration, what red list species is occurring here. So this is something that we could easily fix, and that is to me a priority for halting biodiversity loss and to take them into account when we make restoration and management plans. Just a hint maybe to Biodiversity Knowledge Hub as well.
I'm afraid that we must close this session. I won't wrap up all the interventions. I don't think it's needed. What we would like to emphasize is that there's a lot of interest here, and there's a need, an urgent need, and we may have the tool in Biodiversa Plus initiative. So let's continue this discussion, and let's figure out the best way to identify areas for restoration, whether priority or not, areas for restoration, because we need to deliver in a very short term. Thanks a lot for the attention and all the discussion, and let's continue.